Hi grade 7s and grade 8s. I'm going to give you some quick notes on some of the things we've learnt in class in both grade 7 and grade 8 geometry so far this unit. These are kind of just some of the concepts, some of the rules and some of the new terms that we've come encounter with. So I'm going to do some of the grade 7 criteria first, and then I'll move on to some of the grade 8 rules that we have created in class. So let's get started. And first things first, I'm going to draw just a straight line. Oops. I'll draw a straight line like so. Now if we wanted to get the perpendicular bisector, so perpendicular bisector, I'm just going to write that down. Perpendicular bisector. We did an investigation in class as to what these two words actually mean. Perpendicular means that two lines meet at a 90-degree angle, and bisector means cutting something in half into two. So we want to find a line that cuts this line here in two, but we want it also to be perpendicular, so creating a 90-degree angle. So first thing, we get our compass, and I don't have a compass on this explain everything. However, we would put our compass on this point here. We'd put the point, and we would measure at least halfway, and we would draw an arc. So it would look something like that. And then you bring the compass over to the other point and draw an arc the other way around. So pretty much what you'll be left with is these two arcs that cut at two bisecting points, and I'll draw those 2 points in. One is going to be here, and the other is going to be here. When you draw a line in between connecting those 2 points, you will find that it bisects your original line, but at a 90-degree angle. So that's how you bisect a line with a perpendicular bisector. Next one we're going to look at is bisecting an angle. So it's the same word, bisector. However, we're going to be bisecting an angle. So if we have an angle, like so, and we want to find out the bisector of this angle. So first things first, again, using a compass, you will put your pin of the compass right here where this red mark is, and you would draw an arc going from one line to the other. So it would end up looking something like that. Then you would put the pin of your compass at each intersecting point and draw an arc like that, and from the other side it would look like that. And you can see that these two arcs intersect right here, and if you join that right back to the middle of your angle, you will get the bisector. I'll do that in yellow. Let's draw a line. Oops. And there we go. And that's our angle bisector. Again, this is still on grade 7 material. Next up is if we wanted to draw two parallel lines. Now, parallel lines are lines that will never meet. So we're going to write parallel lines. They'll never meet. So there's two criteria we need to satisfy. These are roughly two parallel lines. How we can check is the following. We need to measure the distance between both lines at two separate points, at least two separate points. And if these distances are the same, say 3 centimeters, 3 centimeters, then your lines are parallel. However, these measurements, and this is our second criteria, they must be making right angles or perpendicular angles to these lines. So for example, your measurement must create an angle of 90 degrees for each one. So if you get two of them and you find it the same, you can draw in your little symbol that means these lines are parallel and they will never touch. Now, moving on to a topic we looked at last week called dilations. So dilations are pretty much used when you want to, say for example, online, you want to make a photo bigger. You'd grab the corner and you pull it, you'd scale it up in size. And we can do this using dilations for our various polygons or different shapes. So for example, if I just pick a basic square, I'll just move it up here. To do a dilation, you have to pick a starting point first. And we did this in class, and it could be just a point like so, to the left or the right of their shape. Then what you're going to do is draw a straight line through each point. Now, you would use a ruler. I'm just going to do it for ease here through each of these points by hand. Okay, perfect. Then you want to find out, well, what's the distance between this point and this corner? And if I want to double the size of the square, I would take this distance here and I would measure it out here. So I would now draw a mark in here. That will be the new corner of our square. And let's call that, very important to label your points, makes it less confusing. Let's call that point A. Point B, you do the same. You would measure the distance between this point and measure that distance from here out. And you would get your point B would be around here. And then our point C would be the same distance from there to there, out here. And you can draw that like so. This is easier if you use a compass, or you can just use a ruler, but the exact measurements are much better when you use a compass. And then the last point will be point D, and it will be from this distance measured out, because we're going to double it. And we would end up with it being somewhere around here. Mine is just going to look like an approximation because, of course, you're going to use a ruler and exact proper measurements. It would look like, ooh, that's a bit wonky. Let's erase that. It would look like a replica of your original shape, however, double size. Okay, so that's going to be our new shape. I'll write in our labels here. There we go. So this is just a quick example of dilations. We did a lot of this in class with our Mario problem and our shooting star, so this should not be an issue anymore. Now, moving on to more grade 8 rules. So I'm just going to write, this is more grade 8. And we're going to be looking at a few rules that we've came across in class and some of the terminology that we've looked at. So for example, I'm going to whiz through these really fast. First one is going to be, if you have a straight line and you have an intersecting line that creates two angles. One angle is going to be here and the other is going to be here. So for example, if this angle is 35 degrees, this other angle right here is going to be 180 degrees minus 35, because both angles have to add up to give you 180. So this would be 145 degrees. Two angles that add up to give you 180, or the straight line rule, are called supplementary angles. Perfect. If we have an x like so, it's pretty straightforward, and you can see it visually for this one too, that these two angles here, called A and B, are going to be the same. And this is called opposite angles. So A equals B. And vice versa, if we have C and D, we could say C equals D. And this is the opposite angle rule. Next one we're going to be looking at is if we have two parallel lines. These lines are parallel. And we have an intersecting line. So for example, we're going to have this one here. Then these two angles right here, let's call it A and B, are what we call corresponding angles. And these angles are also the same. You can see from the picture they look the same. So A equals B. Also, we can pick these angles in here that will also be corresponding angles, C and D. And they also correspond to each other. And this is what's called our F rule, because it makes the shape of an F. Next one we're going to look at is our Z rule. So if we draw two parallel lines, and then again we draw a bisector line in between, just like so. This time we're going to look at two other angles, and these are called alternate angles. So these two angles here, say A and B, are also going to be the same. So angle A equals B, and these are called alternate angles. Perfect. And these are our main rules for geometry that we're going to be looking at this year. To quickly review the circle, and we're going to draw a circle here. Perfect. Don't like the color of that circle. Let's see if we can make it. Oops. That's okay. Okay, so just to go through our terminology really quickly for the circle, I want to get rid of that dot. There we go. Okay, let's draw a circle down. Perfect. Blue's much better. We want to review some quick attributes of a circle. So let's do that. We have this section right here, or a line drawn between 2 points in the circle that doesn't go through the middle is called a chord. Excellent. This space that the chord kind of cuts off from the rest of the circle is called, anyone remember? A segment. The center of our circle, how do you find it? Does anyone recall? We would get the perpendicular bisector of two chords. That would give us the center when they intersect. So say that's the center there. Perfect. And now let's go through quickly our other terms. A line from the center out to the edge is called a radius. A line from this one side of the circle to the other through the center is called, a straight line, is called a diameter, or D. The total distance around the edge of the circle is called circumference, and that's C. And we've got one more, and I'm just going to shade it in. If we take like a pizza slice going from the center of the circle out to the edge, and take a chunk out of there, this is called a sector. And one more actually before we go. If we take just a line around just a part of the circle, part of the outside, this is called an arc. Perfect. So I hope this helps you just to review the terminology so you can have a quick look when you're doing your practice questions. Thanks, and I'll see you later.